All right. Go ahead and go over part 2. All right. Is everyone there at the homework?
Yes.
Part
Yep.
2? Cool.
Good to go.
So what are the 3 assumptions that need to be checked before we compute a confidence interval for a mean?
These are that it has to be a simple random sample from the population. The sigma must be known, and it has to be a normal distribution.
Or n greater than 30. Right?
Greater than 30?
I don't remember that part. Let me see. Yeah, I don't remember that mean greater than 30, or the n greater than 30 part.
Said it in the video part. It
I think
wasn't.
I think it just means that the distribution of sample means will be normal greater than 30.
Oh,
Yes.
gotcha.
Yeah, so that's greater than 30.
I think it's just
normal.
Yeah, I think it's just stating the same thing in a different way.
Okay, gotcha. Yeah, I didn't watch the video, so.
Yeah.
Okay, GMAT is an admission criterion in many MBA programs. BOA professor like to estimate population mean 50 scores. Sample mean is 541. Assume population standard deviation of 52. Questions. So what is the point estimate for the population mean?
541.
Yep.
Yes.
Create a 95% confidence interval for the population mean while you work it out. So, the way that I did it, I found the sample standard deviation first. So 32 divided by the square root of 50. You get 0.525. And then to find the confidence interval, you just multiply the z-score by your sample standard deviation. So, reading the 95% confidence interval z-score is 1.96. So you multiply those two together and you get 8.87 as part of the confidence interval. So, plug that in. 541 minus 8.87. You get 532.13. You get 549.87.
That's what I got.
Cool.
Sounds good to me.
Cool.
So 9 concept, but with the square root of 100 instead.
Yeah.
Exactly.
So I got 534.73 and 547.
That's what I got.
Yeah, same here.
Cool. All right, number 10. How does the margin of error for the 95% confidence interval sample size 50 compare to the sample size of 100? But I think it's pretty obvious. The larger your sample size, the lower your confidence interval will be.
So then your margin of error gets smaller with the bigger percent, with the more sample size you have.
Yeah.
Yeah.
Yep.
Okay.
Yeah, because everything else is equal. Your z-score is the same. Your population sigma is the same. The only thing that changes is your size. And
Isn't that kind of like the law of large numbers? Like the more sample size you have, the closer it is to the population.
Yeah, I think so. Yeah, I think the homework talked about that, that the law of large numbers plus your central limit theorem is behind how you find the margin of error.
Yeah.
Both of those combined with that. So. All right. On to 11. We're to 90%.
So this one is just the same as 8, except for you're going to change the score. So it's
Yeah.
1.645. 8, 10. Let's see, I got 533.56 and 548.44.
Good. That's what I got.
Yep.
Yeah. Same here. Should be good.
So how does this compare? So the lower percentage or confidence interval will be, the smaller your margin of error will be. Everyone else agree?
Sounds good.
Cool. And then the last one, BYI professor would like to repeat. Everybody wants to make sure he has enough students. Make sure that his margin of error is 5. How many students do they need to have a 95% confidence interval? So just put 5 equals the z-score times the sample standard deviation and solve for the square root of n. So by solving that, I got 158.
158. Okay.
Yeah.
That's what I got.
Cool.
So with this, we're always rounding up no matter what, right?
Right.
Always. Okay.
Because if you round down, then you're going to go outside that interval.
Oh, that's fine.
Cool.
Wait.
So the quiz.
Yeah, let's go.
Sorry if it's loud. I'm at McDonald's. My internet's down at my house, so.
I was wondering what that was.
Yeah,
McDonald's is hopping at this hour.
that's right.
Alright. Make sure you have the probability applet open.
Can someone put in the link for the applet real quick?
Yeah, let me get to it.
I got it.
Thanks, guys. Sweet. Alright, I'm good.
The purity of it is, having these people just be gamers with no agenda, they just want to know if it's fun or not. So Ben wants to filter back to the team. The turns up today's meeting, even surpassing expectations.
The margin of error for a 90% confidence interval and the standard deviation is 50 and n equals 25. So the z-score equals to 1.645. Just plug that in.
We have
What do we put for the point estimate if we don't have the mean?
I just put 16.45, which is what I got.
Wait,
You don't need it.
what? Oh, I don't. Okay. I'm trying to get the intervals, but I don't need the intervals right now. Oh, I'm just, okay. Sorry, I read the question wrong. Just the margin of error. Okay.
Yeah. So what did everyone get?
Is it 16.45? Wait, to the nearest what? 3,
Three.
4, 5.
Yeah, that's what I got.
$16.45?
So I got 16.4. But it says 3 decimals, so do we have to put a 0 behind it?
I don't know.
Yes. Okay.
Did you guys say that 16.45?
Yeah, that's what I got.
Yeah.
Okay. Sorry.
I bet you can't.
Okay, for number, are we on the number 4?
Yeah.
Okay. True. I don't know the names for these signals, but the mean is a point estimator of x, right?
No.
Isn't it the sample mean is the point estimator of the mu? Or no?
Yeah, it's the other way around. So X bar is a point estimator.
Okay. All right, 5.
Yeah. So we're getting a standard deviation, sample size, and point estimator. We just need to find or use that for the next few questions.
Oh, so this is the, so this is x plus or minus. Okay.
Okay, I got 498.315 and 550.5.
Oh, right. I was using the wrong z-score.
Did you get a z-score of 1.766?
No, I was
no.
using.
1.96.
Oh, okay. There we go.
Yeah, I was using 1.645 from the previous problem.
Okay.
So I got 498.315 for the lower limit, and then the upper limit is 553.85.
What'd you get again? Sorry, you cut out.
I think.
Which one, the lower or upper?
Both of them.
Lower 498.315, upper 553.685.
What I got.
What was the upper? Sorry, you just kept like breaking out.
553.685.
Okay.
And then what would happen to the width of the confidence interval if you increase the sample size?
Smaller, right?
Yeah.
Decrease.
Yeah.
Almost.
What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
What is this?
Yeah.
Decrease again?
No, it would increase
Increase?
because you're increasing the z-score.
Oh wait, I'm confused. Even though our confidence is going up? Oh, the confidence interval. Oh.
So
Okay.
if it's relating to the sample size, it's the opposite effect. If it's relating to the percentage, then it goes up or down with it.
Oh, okay. Sounds good. Thank you.
Light bulb company, I think it's to assess the average life expectancy of their bulbs. You know, the standard deviation is 400. They want a 95% confidence interval with a margin of error of 50 hours. So what sample size did they need? So
The confidence. Okay. Oh, margin of error. That's the. Okay, I'm trying to think how to set this one up.
So you put 50 equals the z-score, which is 196, times sigma, which is 400, divided by the square root of n. And then you solve for n.
Okay, so that's also the. Okay, got it. So that's also n equals 1.96 times 400 divided by n, or divided by
50.
squared, right?
Yeah.
Okay.
Do you have to do the square root of n equals 96 times 40 divided by 50?
Yeah, and then if you square both sides, then you'll get n.
Okay.
So you have to go up, or no? Is this too many whole numbers? Did you get 246?
Yeah, that's what I got.
$246.
Did you guys all get 246?
Yeah, that's what I got.
I did.
Cool. Is everyone good on 9?
Yes, now I'm good.
Okay.
All right. Mean salary of actuaries is 100,000. Standard deviation is 36,730. You're interested to know if the mean salary for women is different. We're not sure if it's higher or lower. Set up a hypothesis test with level significance 0.05. And then you have your null and alternative hypothesis. You collect a simple random sample of n equals 36. Find that x bar equals 111,000.
Okay, so this is x plus or minus 1.96.
Yeah.
Okay. The standard deviation is 3.
So in this situation, why is x in the formula different than the mean? Oh, because this...
So we took a sample of women from the population.
You always use the sample mean.
All three of them have all kinds of different types of music. So it's like, so it's sort of, sometimes if you have too much going on, it can be, sort of just that one guy control the music. And, I think it's great. It creates a nice atmosphere.
What'd you guys get?
I've always wanted
The lower I got 99,002,
to
and the upper I got 122,998.
What'd you get for the lower, you said?
99,002.
Mm-hmm.
Is it pretty consistent, or do you change with your mood? Do you change maybe what's going on with your golf swing?
I change with my mood or what I'm into at that time. If I've heard a good song from an artist that I thought was
So we call it x bar, so it's 11. Okay. Right? We're adding and subtracting it from 11.
House music.
Oh, what is house like? House
I didn't like hear what you were saying.
It's like dance music, sort of upbeat. I guess like I don't know, like never.
You big skill? Four. So you agree that we like to listen to music, but we just
Don't listen to the same music exactly.
Have you ever gotten a song caught in your head? Say, open chance.
Yeah, I had the Adele song stuck in my head. Heard of her. You've heard of Adele. Alright, that's how to that's a start.
What song was it?
Rolling in the Deep. There you go. Yeah.
Can anyone hear anything? You guys,
But I still get uncomfortable watching you do that.
Is everyone good?
Okay, so what did we
11.
I can't hear what she was saying. I think mine is way off. I wrote it inside, but I can't hear.
Hey, Eric, I'm going to mute you real quick. There.
Oh!
Sorry, Eric.
It's McDonald's.
So I got 99,002 and 122,998.
122,998, right?
Yeah.
That's what I got.
So that was 100. So that was 122,998.
Yeah, let me type it in. There we go. All right. Sorry, I muted you there for a second, Eric.
No, it's fine.
Here. All right. Cool. Number 12?
Yeah, let's get it done.
All right. 3 requirements when computing a confidence interval. They are,
All of the above, right?
yeah. That's right.
Yes.
Cool.
This might be our fastest meeting yet.
I know. It's pretty simple.
Okay, I'm submitting.
Sweet.
Cool.
Yeah, I got 100, so.
Thanks for waiting, guys. Appreciate it.
Yeah, you're welcome. All right, see you Thursday night.
Okay, bye-bye.
All right.
All right, bye.
I'm